Hello dear students, today we are going to start the second unit of our syllabus. The second unit is about refraction and reflection. The note for this particular video has already been shared in the Google Classroom. So you can go through the note before watching this video as well as after watching this, so that you can understand, you can get to know whether you have totally covered the idea of that derivation or not. So you can see that we have we basically have a spherical surface like this, and a spherical surface which is having a refraction, okay, and a ray of light is coming out of the axial point. So you can see that this is the axis of the of that particular spherical surface, and the ray of light is coming out of O, and it is coming to the point, okay, to this point. So I will name it as S, okay. Now as usual, this is particularly separating two media, okay. So I will name this medium as refractive index n1, this medium as refractive index n2, and so I will at this point I will try to draw a tangent. I have drawn a tangent like this, and I will draw a normal, okay. So the normal will, I have drawn a dotted line, so let me draw it as a dotted line. So this is a normal drawn at the point of incidence. What is the point of incidence? S, okay. So as a ray of light is going from a rarer to denser medium, it will come closer to this part. So the ray of light was actually supposed to go in this direction if the lens is not there or surface is not there, but since the surface is there, the ray of light will not go like this, but it will bend towards the normal. So it will go like this, okay. It's very easy. Now this is the ray of light, this is a refracted ray of light, and let us consider this meets at a point C, and what we are going to do, let us consider the point S has a height, it is at a height h, okay, from the axis, and this point is P, and this point is say, I will name it simply, let me see, I will do it according to the book that we have been using, so that it becomes uniform for all of you, okay. And fine. So let us consider that this is the angle alpha 1, okay, alpha 1, and this is the angle alpha 2, and this angle is beta, okay. And suppose that I will just mark an imaginary area here like this, and see, suppose this is not C, this is the image, here the image is formed, this is a sorry, this is the center of curvature, and here we have we will draw a line here, okay. These are all imaginary, just bound the limits, okay. So image, suppose image distance, this is the image distance, let it be given by y, okay, and this distance, let it be given by radius of curvature, let it be by small r, okay. And this is the angle of incidence, this is the angle of refraction, okay. And I will, this is also, this is the object, so I will, obviously this is called the object distance, so it is x. So you can understand, x is the object distance, y is the image distance, and r is the radius of curvature. So C here is the center of curvature. That's all we have. So these are about the specification of various things that we are using in a diagram, okay. Now let me remove all this. I hope you will remember these things, okay. These are already mentioned in the note that we have provided. So this is about the ray diagram. So always remember that you should be very much clear about the ray diagram. Now from the diagram, okay, now you need to keep that thing in mind. From the diagram, you see, if I want to write angle of incidence phi 1, okay, phi 1, can it be written as, see, look at the triangle SOC. Look at the triangle SOC. Okay, so is it alpha 1 is phi 1 is the external angle, so phi 1 is nothing but alpha 1 plus beta. Am I correct? Okay, that is the first thing that we have. And then if I want to write phi 2, okay, so for phi 2 you can see, if I consider the triangle, okay, I will not write it directly. Let me consider the triangle, say SOI. In the triangle SOI, okay, no, we cannot do like that. So in the triangle SCI, okay, you can see that phi 2 plus alpha 2 is equal to beta. So if I want to write phi 2, it will be equal to, because beta is the external angle in that triangle, so phi 2 will be equal to beta minus alpha 2. Okay, so we have phi 2 equal to beta minus alpha 2. Okay, and phi 1 equal to beta plus alpha 1. So let it be equation number 1 and let it be equation number 2. So let me remove all this. These are not required at all. You can directly write equation 1, okay, if you understand. So summarizing, we have phi 1 equal to alpha 1 plus beta and phi 2 equal to beta minus alpha 2. So this is equation number 1 and this is the equation number 2. So that's all we have from the geometry of the diagram, ray diagram. Now next thing that we need to check is that since we under as I have discussed that all the consideration here will be under paraxial approximation. So in paraxial approximation, you understand that all the angles phi 1, phi 2, alpha 1, alpha 2, beta, these are very small. Okay, they are considered to be very small. So if I consider, say, sin phi, okay, so sin phi is sin phi can be written as, let me write, tan phi 1. Tan phi 1 means nothing but sin phi 1 by cos phi 1. So if phi 1 is very small, what happens? Cos phi 1 is equal to what? 1, and sin phi 1 is nothing but phi 1. So we have phi 1 by 1. Okay, so tan phi 1 is equal to phi 1 for for phi 1 small. Okay, so and for that also phi 1, if phi 1 is small, then sin phi 1 is also equal to phi 1. So if you, for this condition, phi to be very small, sin phi 1 equal to phi 1 and tan phi 1 is also equal to phi 1. So from this what we can write, sin phi 1 is approximately equal to tan phi 1, okay, is approximately equal to phi 1. Similarly, sin phi 2 is approximately equal to tan phi 2 approximately equal to phi 2. So these are approximation under paraxial approximation, but you know that. So similarly, if we have say sin alpha 1 is equal to tan alpha 1 equal to alpha 1. Sin beta is equal to tan beta is equal to beta. Similarly, sin alpha 2 approximately equal to tan alpha 2 equal to alpha 2. These are because all the angles are considered to be very, very small. Okay. So 1 implies what? 1 implies alpha phi 1 equal to alpha 1 plus beta. So phi 1 is nothing but sin phi 1. All right. Alpha 1 is nothing but tan alpha 1. So alpha 1 is equal to tan alpha 1. So we are just applying some mathematical trick. So beta is equal to tan beta. So tan beta. Again, you know that suppose if I want to get tan alpha 1, tan means base by perpendicular by base. Okay. So where is alpha 1? If you go to this, if you take this triangle, so tan alpha 1 is equal to what? What is the perpendicular? Perpendicular is h. Okay. And what is base? Base is x. So tan alpha 1 is equal to h by x. Similarly, tan beta, for tan beta, suppose if I take this color, then for tan beta I need to take this triangle. Okay. So tan beta will be again perpendicular by base. So base is ultimately equal to r, approximately. Just we are not writing exact. You might be thinking that this distance is r, but here we are writing this distance to be equal to r. So that's why I am saying that they are approximately equal, because we are considering paraxial approximation. So this distance is not going to matter much. This is the gap, but this is not going to matter much. So tan beta is equal to h by r. Similarly, if you want to write tan alpha 2, for tan alpha 2, sorry, for tan alpha 2 we will consider the triangle, this one. Okay. So again perpendicular is this one. So h by base is actually this one. Okay. So that is equal to y. So actually this whole thing is y. So this is also approximately y, since we are considering paraxial transformation. So this small gap, gap is very negligible. So we are writing s equal to y. Okay. So tan alpha 1 equal to h by x. So here we will write h by x, and tan beta equal to h by r. So this is sin phi 1. So similarly, sin phi 2 equal to what happens? Beta minus alpha 2. So it is tan beta minus tan alpha 2. So tan beta means h by r, and tan alpha 2 means h by y. So this is sin phi 2. But you know that according to Snell's law, of refraction, what happens? Sin phi 1 by sin phi 2 equal to n2 by n1. So n1 psi phi 1 equal to n2 psi phi 2. So n1. So sin phi 1 is equal to h by x, h by r, h by x plus h by r, and n2, so sin phi 2 means h by r minus h by y, h by r minus h by y. So we can take h common from everywhere, so we will be left with 1 by x plus 1 by r, n2 into 1 by r minus 1 by y. So n1 1 by x plus n1 1 by r, n2 1 by r minus n2 1 by y. So n1 1 by x plus n2 1 by y equal to n2 1 by r minus n1 1 by r. So it is nothing but n2 minus n1 divided by r. So it will be n2 by y plus n1 by x. Okay, so this is the last form. So this is so this is not the final one, this is a generalized solution. So we will write down the Gaussian formula. Okay, so we will write down the Gaussian formula for a spherical refracting surface is. Okay, so here x, you remember x is the object distance. Okay, so object distance is generally denoted by u. Y is the image distance, is generally denoted by v. But you can see in the diagram that we will use sign convention. Okay, so you can see that in the diagram x is calculated in front of the, on the left of the spherical surface. This is the left and this is the right. Okay, so everything that is calculated on left of the surface is considered to be negative, and everything considered on this side is considered to be positive. So this is a sign convention. So according to that, here x equal to u, but it is actually x equal to minus u. Okay, and here y equal to v, but actually it is plus v because it is calculated on that side. So and similarly small r equal to, I will consider capital R, and this is also positive because we are calculating on that side. So from that we got, using sign convention, we have got that we will put here x equal to minus u and like this. So if you put all this, what we will get, n2 by v minus n1 by u equal to n2 minus n1 divided by r. Okay, so this is the Gaussian formula for a spherical refracting surface. Okay, so this is the generalized formula, so we can also extend it further for all purpose, all the lenses. Okay, which you will get to know up in the further studies.